Let's go ahead and do the second part of our practice calculation. I hope everybody's working hard and paying good attention. I know the MCAS is going on for some students, but that doesn't mean the rest of us can't continue on. Keep calm and carry on. Okay, so here what I want you to do is I want you to write the equation. So if I ask for speed, you know speed then is distance divided by time. So this should be distance divided by time. Okay. Let's see, distance. If I want to calculate distance, then I need to do speed multiplied by time. So I'm going to go speed multiplied by time. Okay. And if I wanted time, I got to do distance divided by speed. So it's distance divided by speed. And let's go on to the next one. If I want acceleration, I'm going to do, this is equal to velocity divided by time. Go ahead and put the equal signs on these. Okay. If I want velocity, I'm going to do acceleration multiplied by time. And if I want time, I got to do velocity divided by acceleration. Okay, now let's look at force. If I want to calculate force, I need to multiply mass and acceleration. If I want to calculate mass, I need to do force divided by area. Force divided by, acceleration, not area. And if I want acceleration, I need to do force divided by mass. So now here I want to calculate force of gravity. If I want force of gravity, I do mass multiplied by gravity, mass multiplied by the acceleration of gravity. If I want mass, I do the force of gravity divided by gravity. If I want gravity, which is a calculation you probably won't do, you do force of gravity divided by mass. So force of gravity divided by mass. Momentum. Momentum we represent with a P, and so to calculate momentum we would multiply mass multiplied by velocity. All right, we want mass, if we want mass, we would do momentum divided by velocity. And if we want velocity, we would do momentum divided by mass, momentum divided by mass. Okay, those are all the equations that we can get from these triangles here. So let's continue on to number 16. If I want to calculate work, I'm going to do force multiplied by distance. If I want force, so work is force multiplied by distance. If I want force, I need to do work divided by distance. Work divided by distance. Now if I want distance, I need to do work divided by force. Work divided by force. Now power. If I want power, I need to do work divided by time. So that's work divided by time. If I'm going to do work, I'm going to do power multiplied by time. And if I want time, I need to do work divided by power. Now let's do wave velocity. Wave velocity is equal to frequency multiplied by wavelength. So frequency multiplied by, I'm going to represent wavelength with an H. Frequency is velocity divided by wavelength. And wavelength here is velocity divided by frequency. Period. Period is 1 divided by frequency. 1 divided by frequency. Frequency is 1 divided by period. And now kinetic energy. kinetic energy, if we want kinetic energy, we do 1/2 multiplied by mass multiplied by velocity squared. 1/2, let's do this here, equals 1/2 multiplied by mass multiplied by velocity squared. And let's square that, okay? And if I want mass, I need to do kinetic energy divided by 1/2 divided by velocity squared. Okay, go. And potential energy. Potential energy is mass multiplied by gravity multiplied by height. Mass multiplied by gravity multiplied by height. Mass. Mass is going to be potential energy divided by gravity divided by height. Potential energy divided by gravity divided by height. And then height is just potential energy divided by mass divided by gravity. So potential energy divided by mass divided by gravity. And that's not too difficult. You're just using the triangles to determine the formula or the equation or the calculation you need to perform. Here's more practice identifying what you need to calculate. Let's see here. So the question, these are the questions. And here I want you to write what you need to calculate. So how much energy did the student complete? Number 13, determine the power applied to the box. What was the final acceleration? So final acceleration, determine the kinetic energy, the maximum kinetic energy of the box. What is the potential energy of the car traveling down the road? How long did the student take to travel? This is time. What is the initial temperature? This is temperature. Calculate the velocity of the train. Determine the amount of power. How much work was accomplished? And what is the final temperature of the object? 23, how much work is required to lift the object? 24, determine how much weight is on the planet Mars. What is the mass needed for an object to have 30 joules of potential energy, and determine the period of the wave. So here, period. Let's see, calculate the mass of the object. 28, what is the velocity before the collision? 29, what is the final temperature? 30, what is the wave frequency? 31, what is the period? 32, what is the frequency of the wave? Determine the frequency of the wave. 33, potential energy. So what is the potential energy of the car? And 34, determine the power completed by the student. And 35, determine the work completed. Work completed. Okay, next. What a wave has a period of 0.5 seconds to determine the frequency. So what do we know? We know that the period t equals 0.5 seconds. What do we need to calculate? Frequency. And the equation we're going to use is 1 divided by the period. Okay, so I want you to calculate that, put the numbers in, and determine the value. So wave has a period of, so similar, a period of 0.2 seconds. We need to calculate frequency. And how do we calculate frequency? If we go up high, up here, frequency. Frequency, where do I calculate frequency? No, not that one, because I don't have velocity and I don't have wavelength. But this frequency here, 1 divided by period. Okay, and now this is the opposite of that calculation. So what do we know? We have a frequency of 10 hertz. What do we need to calculate? Period. Okay, and period, we go up. Period is 1 divided by the frequency. What is F? F is frequency. Okay, so you can just put the numbers in there. Okay, 36, 37, 38. So here you just put 10 here, and then you do 1 divided by 10. Okay, car has a mass of 10 kilograms. And here we have a velocity of 2 meters per second. It says determine the kinetic energy. And kinetic energy, if we look here, is 1/2 multiplied by mass multiplied by velocity squared. Multiplied by mass multiplied by velocity squared. And don't forget, another way to write this is, let's see here, how can we write this a different way? We could do 1/2 multiplied by mass multiplied by velocity multiplied by velocity. Okay, and this down here is very similar. The only thing that's changed is the mass is 2 and the velocity is 3. Very similar calculation for 40. I just want you to put the numbers in there and then calculate the value. All right, here we have mass of 5 kilograms, height of 10 meters. It says determine the potential energy. Let's see, it says determine potential energy. Let's go up here. How do I calculate potential energy? Ah, look. Potential energy, mass times gravity times height. Mass times gravity times height. Put those numbers together and calculate. All right, a car has a mass of 500 kilograms and a height of 2 meters. So we have, actually, so this is a very similar calculation to this here. So I'm going to put that there. The only difference is the car has a mass of 500 kilograms and a height of 2 meters here. Okay, so use these numbers to perform the calculation here. And don't forget that gravity, the acceleration of gravity, is, we can round it up to be 10 meters per second squared. Okay. All right, a car has a velocity change of 10 meters per second. So the change in velocity is 10 meters per second. The time is 5 seconds, so we want to calculate the acceleration. So we want to calculate and determine acceleration. So let's go up. We have velocity, we have time, we want to calculate acceleration. So let's go up. Let's see, oh, we have velocity, we have time, we want to calculate acceleration. So acceleration is velocity divided by time. So just put those numbers in the equation. Very similar calculation here. The velocity change here is 20 and the time is 4 seconds. Okay. Let's see here. A student pushes with a force of is equal to 5 newtons. Distance is equal to 2 meters. Determine the work. So we're going to calculate work. And we have force and distance. Let me turn it off. Thanks, Chief. Okay, so we want to calculate work, and we have force and distance. So let me go up top. Where can we calculate work? Work. We have force and distance. Work is force multiplied by distance. equals force multiplied by distance. Okay, so I'm going to put that here. Same, so just finish that calculation using those numbers. You multiply force and distance. Now we're going to go here and do the same thing because it says a student pushes with a force of 10 newtons, distance of 5 meters, determine the work. So your force is 10 newtons, your distance is 5 meters, calculate the work. Okay, next, what is the weight of a cat with a mass of 5 kilograms? So let's go up to figure out how do we calculate weight. So we know we have a mass of 5 kilograms. We want to determine weight, so how do we calculate weight? Let's go up. Weight. Here, weight, force of gravity. We need to multiply mass and gravity, or the acceleration of gravity. So let's go here. We want to multiply these two. And so mass is 5 kilograms. So you want to multiply mass and gravity. I'm not going to put in the numbers for you because that's a little bit too much, but the gravity is 10 meters per second squared. Okay, our next 48 is a very similar calculation. What's the weight of a dog with a mass of 10 kilos? So the mass changes, the gravity doesn't, because here we're assuming we're on Earth, all right? We don't really have dogs or cats on any other planet. So multiply the mass and gravity together to get your weight. 49 and 50, all right? We're reaching the end of the long haul here. So determine the power if you complete 10 joules of work. So you're doing work equals 10 joules in 5 seconds. 5 seconds is a time. So you want to do power. We want to calculate power. So determine the power. Power equals work divided by time. Okay, so just put those numbers in. Next one, very similar question. Determine the power that it takes to complete 50 joules of work in 2 seconds. Again, we're calculating power. You're going to take 50 joules of work. It's done in 2 seconds. So you have to divide the work by the time to calculate the power. All right, so get this done, and I want you to just go through, complete 1 through 50. It's not as bad as it seems. These calculations are ones you've done before. Okay, thanks.